I'm not joking. The release of Strawberry or QSTAR algorithm by OpenAI yesterday is the biggest piece of news and the most important development in the AI world in the last 2 years since the release of ChatGPT. It's massive and it has tremendous implications for the business. And if you want to find out more, just listen to what I have to say. So why the big fuzz, first of all? The main weakness of the LLMs has always been reasoning and its ability to make meaningfully good decisions. And that was the difference between what LLMs could do and what people could do, because people could sit down, think through the stuff, analyze it from different perspectives, apply different mental models to a problem and solve it. Now this problem is gone. It's solved. So let's talk about that. Let's talk about how OpenAI actually did that. You remember for a year now, we had the rumors of these QSTAR algorithms. So this is what it is actually. They have applied a large-scale reinforcement learning algorithms to teach model how to productively use chain of thought and tree of thought methodologies to achieve the best results possible. What they have done here is they have enabled another scale. The models can now think. They take time to think, they take time to analyze, but with taking this time, they're actually producing significantly better results, drastically better results than ever before. Let's take a look at some of the benchmarks. So look, it's not a surprise. The O1 model, which is what this Strawberry model is called, beats GPT-4o hands down on every metric, on every last one of them. Well, actually, except one, except for the time, because it does take more time on the O1 to solve most of the problems. Most impressively, it beats it on the math benchmarks and on the science benchmarks. So those that require advanced level of reasoning to achieve, any meaningful results. So how do they do that? What they seem to have done is to create an algorithm that for any given problem comes up with the optimal chain of thought approach, then runs through that to analyze a problem from all the different perspectives that you can have to spit out the correct result. Let's take a look at one of the examples that they provide over here on the website, actually. You can look at it yourself, but the basic prompt is the following. They give it some encoded text, give the translation of this text over here and saying, okay, using this information, decode the text below. And this task is completely unmanageable for any of the raw LLMs, pure LLMs. It can only be handled by the pretty sophisticated chain of thought. So if we open up this chain of thought tab over here, we can see that it goes through the rigorous analysis of the problem. It applies different methodologies and different assumptions towards this problem. Then even thinks over here saying, is that the case or is that not the case? And eventually it lands on the proper solution. I don't want to go through the entire thing, but you get the idea. It's decoded by, at the end of the day, it is decoded as there are 3 R's in the Strawberry. In the meantime, I want to talk about the fact that they actually found a way to apply the agent workflow. They really took the agent workflow, which is a multi-step kind of reasoning, and applied it directly to the LLM with a more sophisticated and effective algorithm that they developed with this reinforcement learning. And somehow they taught the system to recognize its own mistakes in the process of analysis and to understand which tasks are a little too big to solve, to split them down onto the subtasks and get the right answer. If we ask it to, say, solve an advanced math problem, it gives us the same math problem every time. But what you will notice over here is that it takes significant amount of time for that to think through that. And if you open it, you can actually see some of the steps for the problem solution, but not all of them. And we'll talk about that in a second. So as you can see, it's running quite a sophisticated analysis. It's deciding that it needs to determine the parameters, sphere radius, analyzing the problem, identifying constraints. And the thing is, This set of steps is not fixed. Unlike most of the current sort of multi-step prompting techniques, the sequence of the steps is fixed. Over here, they're dynamically coming up with the sequence of steps, which is optimal to find the resulting solution. As you can see, it takes time, and that's fine. That's how it should be for complex and sophisticated problems. Now, what are the limitations? You may have noticed that there is no ability to upload a file or image or something like that to then analyze it. And also, it has no connection to the internet. And also, it is limited to the threshold of October 2023. So this model is wonderful for reasoning, but it has less agentic capabilities, unlike GPT 4.0 models and the rest of them. Okay, so now it responded. It took 1.5 minutes for the system to solve this problem. It went through a number of sophisticated analytical steps that I don't even understand. And at the end of the day, it spits out the answer. I'm only assuming that this answer is correct, but if they put this example over here, it probably is. So now I want to talk about something quite important that they outlined in their presentation and in their article. They have chosen to hide the chain of thought reasoning from us, from the users. So the raw, detailed way that LLM arrives at the answer, all those super detailed thinking steps, is not something we're going to see. And they give an interesting reasoning to that, multifaceted reasoning that shows that, well, listen, we want to analyze that, and we want to, where's the safety section? Oh, there you go, hiding the chain of thoughts. They want to have an ability to analyze it. They want to have an ability to read the mind of the LLM. And most importantly, I think most importantly, they see that this chain of thought prompting that they're hiding is their competitive advantage, is something that they consider too important to share with the world. And that makes sense. We came to the point when we recognized that the way the model thinks and makes decisions becomes a competitive mode in the business world. And if that sort of direction keeps going with the reinforcement learning and the different chain of thoughts approaches for more deep thinking, I think other companies are going to do basically exactly the same. What also concerns me in that situation is that they're not just hiding it from us, but they're also saying that they want to read the mind and analyze those thought processes, which means that there is at least an intention from the OpenAI side to read this information from our queries and our requests and do something with that, which I don't find very comforting. It took some time actually for them to recover from the initial issues. If you can remember back 2 years ago when ChatGPT was released, they were using some of the information of the free users to train their systems. And after that, the reaction on the market was quite drastic in terms of people didn't trust their data to be sent to any LLMs, even though OpenAI, well, hopefully was the only one who ever said that they would do that. They stopped doing that almost immediately, as far as I can remember. And now I think it feels like they're coming back to this practice of using this data somehow to better understand the thinking process behind the LLMs. I don't know, might be wrong, but that's my hypothesis. Now I want to talk about the implications. And so what we have unlocked with this model is a new dimension. And this dimension many people have been waiting for. So now we have really 3 of them, I think. The first one is the amount of compute. So if you have enough compute and you can scale it, the intelligence of your core LLM will scale with it. Of course, if you have enough data to train, but there are some synthetic data approaches that are working as well. So put it aside, we have a clear scale dependency. The amount of compute you can put into training the system and the time it takes to train it clearly reflects on the system smartness and intelligence. And now we have the second one. The second one is time to think. This system clearly demonstrated that we can now allow the LLM or whatever system, whatever we call it now, to think for extended period of time, and it will give us better results. And that's amazing. That means that LLMs in a combination with these reinforcement learning techniques can be used to solve a lot more sophisticated problems and maybe even apply them in the real world. The third sort of pillar of the smartness of any kind of LLM system or agentic system, because I think that's really what it is the data. The unique data that the original LLM training didn't have access to, and now it does in your agentic workflow. So I think this is quite fundamental. Now we can achieve better intelligence for various problems through either increasing the size of the LLM and increasing the time it takes this LLM to think through the approaches like OpenAI demonstrated with Strawberry, or giving it the data that these LLMs and other algorithms just don't have. I also thought of something else. This release of Strawberry and its ability to think deeper and come up with better answers commoditizes, to an extent, a human's ability to reason, which means that one of the most important skills that humans are going to have is the ability to formulate the problem that LLM with this reinforcement learning technique will take and turn into the solution. This is a very interesting and crucial point. The better you formulate the problem, the more data you give around it decides how well the problem is going to be solved by Strawberry. So look, I think it's exciting times. It really is. Now LLMs will turn from a nice gimmick into something that can seriously impact massively big problems. And I think we should be considered lucky that we're living during that time. Thank you. Don't forget to leave your thoughts down here and also subscribe and like this video.